Alright, let's take a look together on one question. So we have a titration experiments. 20 cubic cm of 0.2 mole per nickel NaOH reacted with 32 cubic cm of sulfuric acid solution. Calculate the concentration of H2SO4 in mole per dm cube and in gram per dm cube. So what I like to do the first step is I write down equation. This is the H2SO4, we have NaOH equations. Find the number of moles first. The number of moles of your sodium hydroxide, it should be 20.0 cubic cm or 20 over 1000 times 0.2, you get the number of moles. After that, I know the mole ratio is between 2:1, so I divide by 2, I get the number of moles of sulfuric acid. I divide it by the volume is how much? 32 cubic cm, so divided by 32 over 1000 is 0.032, so you get the concentration. And let's take a look at number B. So B, I want to find out in gram per dm cube, I find the mass first. After I find the mass, which is the molar mass, I take the mole per dm cube, cross multiply with your molar mass, then you get gram per dm cube. Now keep in mind, remember your mole multiplied by mR, it will give you a gram. So this is what we are doing here. Do not be confused by the dm cube, ignore the dm cube. Just focus only on the mole as well as your molecular weight. That's how you get your mole, how you get your gram per dm cube. Now let's move on to something a bit more challenging. So we have one example here. So a solution of an acid contains 25.2 gram of your diacid. This is diacid, dot SH2O per dm cube. 50 cubic cm of this solution requires 40 cubic cm of 0.5 mole per dm cube or KOH for titration with phenolphthalein as indicator. Calculate the value of X. So I'm supposed to determine the value of X here. So what I do is I find out the molar mass, it will be 90, which is here, plus 18x, because this is dot here represent 18. This dot here represent plus. This H2O is 18, so 18 times x. I want to find the concentration. I do know the mass, so I take the 25.2 divided by the total molecular weight. Then you may ask me, why your mass divided by your molar mass is equal to mole per dm cube? Because it tells me that this is 25.2 per dm cube. So this is actually essentially your gram per dm cube here. This is gram per dm cube. So you see they hide the word like that, right? This is gram per dm cube. That's why gram per dm cube divided by molecular weight is mole per dm cube. Next, KOH. Can I say that you know the volume, you know the concentration, you can find the moles. Then after that, I can write a very simple equation. Now, don't forget it's diacid, so therefore you need 2 hydroxide to react with the diacid inside to become CO minus K plus bracket 2 because you got 2 of them inside. Then plus X plus H2O because this bond will be broken apart. It's a crystals, so this is X here, but you produce 2 moles of H2O because 2OH reacted with 2H. So it's 2H2O. Then so it's X plus 2H2O. Then from here, I will be able to determine the number of moles of your acid. So you know the moles of this one, divide by 2, you find the number of moles. Then can I say that you want to find out the concentration of this compound here? How do I do it? So I find the concentration, very simple. You take the mole divided by the volume. You see this one is 50 cubic cm. So you take the mole divided by the volume, 0.2 mole per dm cube. After you get the concentration already, can I say that this also represents your concentration? So this concentration, you go to 0.2. This one is obtained from earlier partner. So you cross multiply, solve X, and it's equals to 2. And that's how you solve the answer. Okay, next one we're going to go through is one very, very important concept. It's called BACK-Titration. So I need you to put a star on this particular page. Very, very critical. Whether you're at J1 or J2, this will be essential not only for your practical, also for your examination. If you don't know this, you cannot do a lot of calculation. So let's take a look together on this question. An impure sample of magnesium hydroxide has a mass of 1 gram. And 100 cubic cm of 0.4 mole per dm cube of nitric acid was added to the sample. After all the magnesium hydroxide has reacted, the excess nitric acid in the resulting solution required 20.5 cubic cm of 0.7 mole per dm cube potassium hydroxide for neutralization in the titration. Find the percentage by mass of magnesium hydroxide in the sample. Now I know most of you finished reading the question, maybe your soul has left your body. But the key about this question is, you need to try to draw a very simple diagram to analyze what's going on before you proceed. So that's why we draw a diagram here. This diagram is not given in exam. You have to draw a very simple flow chart to understand what the question is asking from you. Then you know what to do. So they simply describe that there's an impure of sodium or magnesium hydroxide here. I don't know how much of magnesium hydroxide is present, so I put in a lot of acid. And the purpose of adding so much acid is to make sure all the magnesium hydroxide is fully reacted. Then you form the target salt. But there will be some, acid left over. So this acid, what we do is we're going to titrate it with a known concentration of your base. In this case, potassium hydroxide. And if you titrate it, it's on the burette, definitely you know the volume. So that's why concentration and volume is known. So can I say that if you're able to know the moles of your KOH, you know that we will be able to determine the moles of HNO3. And this HNO3 you found out is the leftover. Do you know the initial? Yes. So you take the initial, subtract the leftover, what do you think it becomes? It becomes the amount that reacted with magnesium hydroxide. So that's why we call it back titration, because we're working from the back all the way to the front to find out the number of moles of magnesium hydroxide. So let's take a look how it works. So the first step is I like to write down both equations, what's going on. Magnesium hydroxide react with nitric acid to give you this equation. Then reaction number 2 is the key one we are looking at because we're looking from the back to the front. So this nitric acid plus potassium hydroxide give you your salt and water. So the first step, what I'm going to do is I'm going to calculate the excess of your reagent, which is HNO3. You are given that already, 100 over 1000 times 0.4, because we are told of the concentration as well as the volume. So this is what exactly we're doing here. After you got this already, then we'll move on to the next step. The next step is move from the back already. So we go all the way to the back. We find out what is the number of moles of your HNO3 that has been left over, called the remaining. 20.5 divided by 1000 times 0.75. So you get the number of moles of your nitric acid. This is the remaining. Remember remaining amount? Do you know the initial? You know the remaining? You find the difference. 0.0246. So once you know the number of moles of your nitric acid already, which is the amount reacted with magnesium hydroxide, can I say that I do know the ratio between your nitric acid and magnesium hydroxide? 2 is the what? 1 here. So what do? You simply divide it by 2. That's why divide by 2, 0.0123. Oh, that's a good number. Then after you get the number of moles of your magnesium hydroxide, this will be the so-called the pure version. Because only the pure can react nitric acid. That's why we know this must be the pure number of moles. So I multiply by the molecular weight. This amount must be the pure version of magnesium hydroxide. The 1 gram is the impure. So to find the percentage purity, 0.717 divided by 1 times 100%. So you get 31.7%. That's how you solve the questions. Okay, so what I want you to do is that try it again and reread the question, understand the whole story behind it. After you got it, then you move on to the next page, try that checkpoint. If you're able to do the next checkpoint, that means you got the concept. Now remember the key is draw a very, very basic diagram, a flowchart, to see what is going on from the start to the end. Don't try to visualize from your brain unless you are very, very familiar with back-titration. If you are not familiar and it's the first time you're learning it, just draw a very simple flowchart. Then you can understand the flow, followed by proceed with the working. Alright, so put a pause on the video, go and try the checkpoint on the next page. And I will see you later. Okay, good. I hope that you actually have tried out the checkpoint before you look at the solution, because you don't do that, you won't be able to understand what's going on. So I believe you have read through the questions already, so I will just go straight to the point in terms of the flowchart. So you see I draw a very simple flowchart. Oh no, artist, you see I just draw box to understand what's going on. So we have two different things, calcium carbonate, calcium chloride. So if we have what? Your acid. But many people may think that, hey, can calcium chloride react acid or not? What do you think? Obviously not. Calcium chloride is a salt. It don't react with acid. So we'll leave it alone. Don't react. Just don't react. If your mom buy for you 10 dishes on the table, doesn't mean that you eat all the 10 dishes. Nobody say that. You can choose the dish you want. Similarly for acid, you can choose what they want to react. They only react with carbonate. That's why the first reaction is carbonate plus acid. This is the impurity that don't react. Now we know the story. The acid is likely in excess. So that's why some acid left over. Now, you know that, right? Before dilution, after dilution, remember the earlier part of the questions that we did? Before, after, the number of moles are the same or different? They are the same. So the number of moles are the same. So do not get confused, It's the same. So they're saying that you get the remaining mole, you dilute all the way 250% of water, it will be the same number of moles. But out of this volume, how much it took out? 25 cubic cm. Also, that means the number of moles to take inside is only 10%, because only 25 out of the 250 is taken out for reaction. Then they say that this amount requires this amount of base. So I can know the equation because HCl can react with NaOH to give you NaCl and water. It's a 1:1 ratio. So what do I do here? Work from the back all the way to the front to find out the number of moles of a calcium carbonate. Then you can determine the percentage by mass of your calcium carbonate, which is percentage purity. So let's take a look how it works. So the first step is I'm going to write down the equation HCl react with NaOH to give you NaCl and H2O. Working from the back to the front, find the number of moles of your NaOH, which is the number of moles of your HCl as well. Then I want to find out what is the original amount in 250 cubic cm, which is so-called the remaining leftover, because you need to take out 25 cubic cm. So your 25 cubic cm here actually represent your 2.105 times 10 to the power minus 3. I want to find out the original amount in 250 cubic cm. So it's a 10 times. That's why you see I take 250 over 25 times the number of moles. So I know this number of moles is this one. And don't forget, this and this number of moles, same or different? They are the same. So this number of moles I know already. Do I know the initial amount of a HCl? Of course, it's given to you already. So you find the moles, take the difference. This will give you the amount of moles of HCl reacted with CaCO3. Then what do I do next? You write the equation. CaCO3 we have a HCl to give you CaCl2 plus CO2 plus H2O. Then after that, I know the number of moles of HCl. Can I find the number of moles of calcium carbonate? Of course. So you simply take the number of moles, which is here, divided by 2, because this 2 is to 1 ratio. So you halve it. Then after that, you find the number of moles, you can find the molar mass. After you find the molar mass, you take the molar mass multiplied by the mole here, you get the mass. Then you take 1.45 divided by the original mass times 100%. This will give you percentage purity, or the percentage by mass of calcium carbonate.